All right, so today we're going to look at what's called the natural log. There were two special logarithms that I told you about. One was the common logarithm, that's the log with the base 10. And now we're going to look at another special one called the natural log. And we use this, in natural logs, we use this number e. It's just a symbol for a specific number. And if you find your e to the x button on your calculator, all scientific and graphing calculators have them. So find your e to the x button. And if you put in e to the first power, so put a 1 in for x, e to the first, that's going to tell you what e is. All right, e to the first is what e is. And so it's a decimal. It's irrational. It goes on forever. It goes all the way across your screen. It just keeps going forever. It never stops, never repeats. It works, I mean, it's kind of like pi. Pi never stops, never repeats. And we use the symbol pi. Okay, so this is just the symbol for pi. And then we can approximate its decimal as, 3.14. So e has a special number, and you can see it on your calculator. And we could round that also. If we go 3 decimal places, it's about 2.718. All right, so that's what you should see on your calculator if you put e to the first. All right, so that's the decimal 2.718. So it's close to 3, like pi is. Now, this e number is used when we talk about finance. Usually, we're going to use it when we talk about investing money, and we talk about compound interest. This number e is used in a formula, and then we can calculate the interest or the time that it takes to get a certain amount of money once we invest it. All right, so this number e is going to come back into play. So now if we take log, L-O-G, and we put it in as the base for the log, then we get this natural log, special log, ln. So this is L, not I. Some people see it as an I. So ln represents the natural log. And that's a special log that has e in the base. Okay, this 2.78 number. Okay, so you'll never see an e in the base of a log. Okay, you'll see it written as ln. And so anytime you see ln, that means log with base e. Okay, so this natural log is on your calculator. That's the ln, and it's probably right near your e to the x button. Usually it's just above it. It's usually the shift or the second key. But that ln key is on your calculator, and it's calculating log base e. All right, now all the properties that we just talked about with log work with ln also. Exactly the same properties. All right, so if we want to evaluate these logs again, kind of look back at what the properties were from yesterday with log. So if we want to evaluate or simplify ln e to the third, if we recognize that ln again is log with a base e, then if we put this e to the third next to it, this should simplify down to 3. And that's because of the property we talked about yesterday. When the base and the number next to it are the same, then the exponent will be the answer. All right, number 2, ln e. So what would ln e simplify to? Yeah, perfect, okay? Because ln, again, is log base e, and then we put the e next to it, and then e is the same, so we take the exponent, which is 1. All right, number 3, e to the ln 8. What would that simplify to? Perfect. Okay, so again, the log is up in the exponent. So ln is the same as log base e, and since these are the same, the answer has to be 8, because those have to be the same. All right, number 4, ln 1 over e. Good. So 1 over e we can rewrite as e to the negative 1. Because we can take the e that's on the bottom, that's e to the first, and if we flip it up to the top, all we have to do is change the sign of the exponent. And if it's a positive 1 on the bottom in the denominator, then if we move it up to the top, it changes to a negative 1 on top. Now, ln e to the negative 1 simplifies to negative 1. All right, number 5, ln 1. Good, 0. Number 6, 2 times ln e cubed. 2 times ln e to the third power. What would that be? Yes, perfect. All right, so this says 2 times whatever ln e to the third is. And if ln e to the third is 3, then 2 times 3 has to be 6. All right, number 7, ln square root e. All right, so this is a property that we have to remember from last semester, square roots. So the square root of e is the same as e to what power, what exponent? Not 2. It's a fraction. 1/2. Okay? So remember from last semester with the radicals and the fractional exponents. Okay, so the square root of e is e to the 1/2 power. And that's because there's an index of 2 right here, and the exponent on the e is 1. So it's 1 over 2. All right, so ln e to the 1/2 would simplify to what then? 1/2. So ln square root e is 1/2. All right, 8, ln cube root e. Yeah, 1/3. That's because ln cube root e is the same as ln e to the 1/3 power. All right, so now I want you to use a calculator. So this is just practicing finding the ln key on the calculator, just like we did with the log key yesterday. All right, so find your ln key, ln 5, and we'll round it to 3 decimal places. So 1.609. So if we were, so remember ln is log base e, so if we put in the calculator e raised to the 1.609 power, so this is our exponent, it should be really close to 5. E to 1.609 should be close to 5. All right, so then the rest of these, no calculator. I was just showing you how to use the calc. So now this is just simplify. Again, PEMDAS, order of operations. So you want to simplify what you can, and you can add, subtract, whatever. So on number 10, ln e to the 4th is what? 4. Plus ln e to the 3rd is what? 3. And 4 plus 3 is 7. Pretty easy. All right, see if you can do the rest of those.